So today's topic is the Klein's construction. So with the help of this method, we can evaluate or draw the velocity diagram and acceleration diagram for a slider crank mechanism. Okay, so this type of method is used for, the first point is for slider crank mechanism. Now with some condition that the crank of the slider crank mechanism moves with constant angular speed, that is omega. And the third point is that it is applicable in case of a slider crank mechanism where the alpha for the crank is given to us as 0. So this type of method can be used to evaluate or to draw the velocity and acceleration diagram for a slider crank mechanism, which moves with constant omega value and alpha is given to as 0. Okay, so let us first draw the configuration diagram for a slider crank mechanism. So this is the one link, another link, this is the piston or slider, that it is the slider. Now this is fixed pin joint, a pin joint here, another pin joint here, and here we have a sliding pair, and this system is fixed. This link is fixed. Let this point is A, this is B, and this is C. Now first let us draw the velocity diagram by using the normal relative velocity method for this slider crank mechanism. Here we can calculate the velocity of B with respect to A as omega into AB. So we know the value of the velocity of point B with respect to A, and the direction can be drawn by drawing a perpendicular on this link AB. So this is the perpendicular. We can also draw the velocity of point B with respect to point C with this direction with the help of this line, which is perpendicular to the link CB, and this is perpendicular to the link BA. And the velocity of the slider can also be drawn with respect to the fixed link in this particular direction, So by using these diagrams and the value of the VBA, we can easily draw the velocity triangle. So let us first select the fixed points as A, then we have this vector, just project this vector here, then we have the velocity of the slider in this direction, you can draw it like this, and the velocity of B with respect to C. So we can take this vector this direction and can project it. So wherever it will cut the horizontal line, that will give us the point C. So this is the desired velocity triangle. So this is the desired velocity triangle. Now according to Klein's construction, in order to draw the velocity diagram, he said that to draw the velocity diagram for the slider crank mechanism, just do one thing, that draw a line perpendicular to this point and another line and extend the link CB to further. So wherever these two lines will cut, fix that point, mark that point. Okay, and wherever these two line cuts, let that point is P. For example, this point is P. Okay, so this particular triangle as per the Klein's represents the similar velocity triangle as obtained by some relative velocity method. Now, but there is a point that this will exactly look like this triangle when, according to Klein's, we will rotate the velocity diagram by 90 degree in the opposite direction of omega. So omega is in this direction. So if we rotate this particular diagram in opposite direction by 90 degree, then that will give us a similar triangle like the triangle ABP. Okay, so let us rotate this triangle by 90 degree. So if we rotate it by 90 degree in the anti-clockwise direction, then it will look like, for example, this will be the AC, this will be the AB, and this will be the vector BC. So this is obtained by rotating this particular triangle by 90 degree in anti-clockwise direction. So this is point A, this is point C, this is point B. Okay, A to B. Now this triangle number 1 and the triangle obtained with the help of the Klein's construction, triangle number 2, are similar triangle or 1 and triangle 2 are similar triangles. So the ratio of their sides will also be equal. Let us write the equation then. So with this similar triangle, now let me also write the values that this arm represent the velocity of B with respect to A, this arm represent the velocity of C with respect to E, this represents velocity of B with respect to C, like this. BC, CA and BA. So with these two triangles, by applying the similar triangle theorem, we can write that BC, that is this arm divided by this arm, so VBC divided by PB is equal to this arm, for example VCA divided by this length PA, so VCA divided by PA equal to VBA divided by AB, VBA divided by AB. I hope this is clear to everyone. Now as we know that the ratio of VBA divided by the length AB represents omega, so this equation can be written as this VBA PB equal to VCA PA as it is given. This value is given or can be calculated. This is equal to omega. So if we want to calculate the velocity of point B with respect to C, then just multiply the length PB with omega. You need just measure this length and multiply with omega. This will give us the velocity of B with respect to C, and similar way we can calculate the velocity of C by multiplying PA, which is this length, and multiplying it with omega. This will give us the velocity of point C, and velocity of point B with respect to A we already know it is given as VAB into omega. So by this method we can easily calculate the values of different points by using the Klein's construction and mathematical relations. So this is how we can apply the Klein's construction method to calculate the velocities. In the similar way, we can also use the Klein's construction to find out the acceleration of different points. This we will do in next video. Thanks for watching.